Good morning, everyone. Myself Sumit Thakkar. Today I'm here to represent an article that is in 12th class physics. The article name is Total Internal Reflection. I'm going to tell you what is the total internal reflection, which uh, which process arises when the light travels from denser to rare matter. Actually, total internal reflections is a basic phenomena of the light which arises when the light travels from denser to rare medium. As you all of know that whenever a ray of light travels from denser to rare medium, the light bends away from the normal. The total internal reflection phenomena arises from this condition. The light when travel from denser to rare medium, it will bend away from the normal. This property of light makes another phenomena that is called total internal reflection. Okay, so let me tell you how the total internal reflections takes place and what are the condition on which total internal reflections works. Your teams can say that the what are the condition at which total internal reflections takes place. Okay, suppose you are having two medium, one is the rare medium and another is denser medium, and I am also mentioned here the refractive index of the rare medium is mu1 and the refractive index of the denser medium is mu2. From this article I will tell you how total internal reflections happens. Let's suppose an object which is lying under the water or under the denser medium. The object which is lying under the denser medium. What happens to that object if it will emit the light? Okay. Okay, let's suppose the object emits the light in this direction. At here, light is moving from denser medium to the rare medium. Here, the angle of incident is theta is equals to 0 degree. As you all of you know that if a ray of light enter from one medium to another medium, if the angle of incident is 0 degree, that means the light do not bends. It passes from one medium to another medium without deviation. That is how this light bends. Okay. Now further, I am just increasing the angle of incident. Let's suppose this ray of light travels in this direction. The angle of incident is I1. Now the light is moving from denser medium to rare medium. The light bends away from the normal. Here the angle of refraction is R1. Okay. From this graph, from this diagram, you can understand that when the light travels from denser medium to rare medium, it will not go straight. It will bend away from the normal. Okay, as gradually we increase the angle of incident. If we increase the angle of incident, let's the ray number second. Look at the ray number second. Here, I just increased the angle of incident. The value of I1 is increased to the value of I1 is increased, and it will become I2. Here, what happens to the light? It will bend more. If you increase the angle of incident, the angle of refraction is automatically increases, because this happens due to the Snell's law. As you gradually increase the angle of incident, angle of refraction also increases. But when you increase angle of incident furthermore, if you increase the angle of incident furthermore, then what happens? At a particular angle, there is a particular angle at which your ray of light bandits or your ray of light travels on the surface. Look at the ray number third. What happens to this process? If I gradually increase the angle of incident from I1 to I2, then I2 to I3, then the light travels from light travels from denser to rare. It will travel to the surface of the light. It will travel to the surface of light. Here the angle of incident is 90 degree. Sorry, here angle of refraction is 90 degree. Okay, this angle at which your angle of refraction is 90 degree is called angle of critical. or you can say that this angle is known as critical angle. Okay. Now further, when we increase our angle of incident greater than angle of critical angle, then what happens? Look at this. If I increase the angle of incident, that is of I4, which one is greater than I3? I3 is our critical angle, I4 is greater than I3. Then what happens? If you incident the light from denser to rare medium, okay, the angle of incident is greater than what? Critical angle. The light reflect back in same medium. Light reflect back in same medium. This process of the light is known as total internal reflection. I hope you will get it. What is the total internal reflection? So there is a two condition of total internal reflection. There are two important conditions. If these two conditions are hold, the TIR will happens. If these two conditions are not hold, TIR will not happens. First condition is light must travel from denser to rare medium. Your ray of light must travel from denser to the rare medium, and another one, the angle of incident should be greater than the angle of critical angle. If angle of incident is less than the critical angle, the light refract here. If angle of incident is equals to critical angle, the light moves parallel to the interface of the surface. If the angle of incident is greater than what? The critical angle, the light reflected back in same medium, or you can say in the denser medium. This process of light is known as total internal reflection. Why it is called total internal reflection? Why total word is added here? Because during the refraction, during the TIR, the energy of light is completely transmitted from denser to rare, denser to denser. Whenever total internal reflection takes place, there is a no loss of energy. You can say 100% of energy is transmitted during the reflection. This is why the total internal reflection is called total internal reflection. So I hope you will get it, my point of view about the total internal reflection. And there is a further some mathematical derivation also in total reflection that will be discussed later on. Okay, thank you for attention, beta.